Welcome to Brain Vision.
We need to find the value of the radius b and the value of the moment about e that will keep this system in equilibrium. So I drew out a free body diagram of the central cog A, a diagram of the cog C, a diagram of the outer cog, and also a diagram of the spider legs. And I also wrote down that the forces F1, so these are forces that are acting on all the cogs, F1, F2, F3. And since this system is symmetrical, we can say that all these forces acting on the cogs are equal to each other. So we're going to start on part A, finding the value of the radius b. And we're going to start working on the central cog A. So I'm going to say that the sum of moments about the point A is equal to 0. And from the free body diagram, we can write that as 3 times the force F, times the radius A, minus the given applied moment is equal to 0. And we can plug in A, since A is given to us as 18. And solving for the force, we get a value of 185.2 newtons. And this is the force that's applied across all the cogs. So next we're going to look at this free body diagram, the diagram of the C cog. And we're actually going to find the force F of 4. So F of 4, that's a force that is acting on the outer edge of the system. So this isn't going to be equal to F1, F2, or F3, since where this force is located is not symmetrical. So we're going to take the sum of moments about the point C, set it equal to 0, and we can write that as the force F times the radius B minus force F4 times B is equal to 0. And these B's will cancel out with each other. So this will become F minus F of 4 is equal to 0. And solving for F of 4, since we just plug in F, solve for F of 4, and we'll see that this force is actually equal to the other forces, F1, F2, and F3. So using the same cog, so we're still on the same cog, we're going to take the sum of forces about the x-axis and set it equal to 0. And we're also going to take the sum of forces in the y direction and set it equal to 0. So looking at that free body diagram of this one, we see that the only force that's acting in the x direction is this F of C of x, so the x component of the force acting on point C. So we can say that F of C of x is going to be equal to 0 newtons. And for the y direction, we can write that as F of C of y minus F minus F of 4 is equal to 0. And we can plug in F and F of 4. And solving for F of C of Y, we'll get a value of 370.4 newtons. So we have all this information about the cogs. So we can now look at the spider legs and solve for unknown values there. And ultimately solve for the value B. So we can write that the sum of moments about point A of the spider legs is equal to 0. And we can write it as 50,000 minus 2 times F times A plus B minus 2 times F times A plus B minus 2 times F times A plus B. Since we know that there's 3 different spider legs, so that's why we write out 3 different equations of the same expression. So we plug in the known values. So we know what F is. And we also know what A is. So we take this equation and we can solve it for B. And we find that B is going to be equal. B is going to be equal to 27 millimeters. Okay, so we now know what B is. So we can move on to the final diagram of the outer gear and use the value of B to help us find what the moment about point E is. So we'll start by writing that the sum of moments about the point A is equal to 0. And from the free body diagram, we can write that as F times A plus 2 times B plus F times A plus 2 times B plus F times A plus 2 times B minus M of E is equal to 0. And we can simplify this down to 3 times F times A plus 2 times B minus M of E is equal to 0. And we can plug in the known values of F, A, and B. So we plug in F, and we plug in B, and we can plug in A, and we can plug in B. Now we take this equation and we can solve for the moment about E, which is equal to 40 Newton meters in the clockwise direction.